Hello everyone. And today we have an analysis of an extremely interesting problem. This is Sudoku according to the rules of arithmetic progression. What does this mean? This means that you need to fill this square with numbers, using the rule that each row and each column of this square should represent an arithmetic progression. That is, any two adjacent squares in any row or column must differ by exactly the same number. Well, let's get started. We have only a few numbers here and in fact nothing else is given to us. But in fact, this is enough for us. Let's immediately outline some rules. Here, in particular, is the growth of progression. It can be positive, it can be negative. That is, the rule by which we will add some variables to the numbers that we already have. Well, let it be from bottom to top and from right to left, just for our convenience. Well, let's try to build several paths that can connect the numbers that we have, because we can only operate with them. Well, let's build the first path, for example, from 1 to 16. Let this be the number 1 path. Let the path number 2 be from 1 to the number 27. I will specifically try to make the paths as close to each other as possible so that we end up with as few variables as possible. I will build the third way from 16 to 21, and the fourth way from 27 to 21. Well, since every two squares differ by exactly the same number, well, I repeat, each row of the column represents an arithmetic progression, then let's set some rules in which, in fact, everything will happen. We will assign to each line, each column, which is used in these paths, a variable by which our squares will differ. Well, let it be variable A in the bottom row, variable B in the top row, variable C in the second column, and let it be variable D in the third column. Well, let's write down some equations that we can make based on these paths. Actually, we will use the equation to draw these very paths. Well, let's look at the first way. We step once from the unit. That is, we had a single 1. In the next cell there will already be 1 plus a, since the arithmetic progression. And then we do 1, 2, 3, 3 steps up, that is, plus 3 ts. And we get the number 16. If the logic is clear, let's proceed to the second way. Actually, it's the same here, only now we step twice from the unit, so 2a and go up 2 cells, that is, plus 2d, and we get the number 27. Similarly, the third way from 16 is 1 up, that is, plus c, and 3 to the right, that is, plus 3b equals 21. Well, the last, fourth way, out of 27, 2 cells up, that is, 27 plus 2d in 2 cells to the right plus 2b equals 21. Well, we can immediately notice that here it is already possible to perform some transformations in these equations in order to make them a little simpler and continue working with them. Well, let's move the unit to the other side. We get that a plus 3c is 15. In the second equation, we also transfer the unit and divide everything into 2. When transferring 1, we get 2a plus 2d is 26, then just a plus d is 13. Here we transfer 16 and get that c plus 3b is 5. Well, in the last equation, we transfer 27, we get minus 6 on the other side, divide by 2 and we get that d plus b is minus 3. Well, we see that we have 4 equations with 4 unknowns. So, since all these equations relate to the same situation, I can safely combine them into a system. In principle, it was possible at the initial stage. Well, actually let's work with them. I will probably take the third equation as a basis, and I will use all the others to express various variables, because I see that, in principle, everything here can be expressed through the variable d. From the first equation, I will express the variable c. C is 15 minus a divided by 3. From the second equation, I will express the variable a through d, that is, a is 13 minus d. Well, I'll leave the third unchanged, c plus 3b equals 5, since I'll substitute everything here. Well, I'll express b from the last one. B is minus 3 minus d. Well, then we do, in fact, a simple action. We begin to substitute everything into the third equation. Instead of c, we will substitute 15 minus a to divide by 3, and instead of a, we will immediately substitute 13 minus d. Well, by and large, we no longer need the system here. Of course, from the point of view of the logic of the design, it would be necessary to carry it to the end, but since here we are still talking about solving the problem, and not about the design, therefore we will cheat a little. That's why 15 minus the bracket 13 minus d is divided by 3, plus 3 multiplied by the bracket minus 3 minus d, and all this is equal to 5. And we get one equation with one unknown, which means we will definitely be able to find the variable d, and already with the help of it all the other variables. Well, let's quickly multiply everything by 3 and perform the conversion. Well, obviously the 3 will leave us from the denominator in the first fraction. 15 minus 13 is 2, and minus by minus will give a plus, that is, 2 plus d. Here, multiply 3 by 3 9, and multiply by 3 minus 27 minus 9d equals 5 by 3 15. Well, minus 8d, obviously we will transfer minus 27 and 2 to the other side and get 40, from where d is minus 5. Well, let's highlight it. And then with the help of d, we can easily find everything else. Well, let's find a right after that, because a is 13 minus d, 13 minus minus 5 is 18. With the help of a, we will immediately find c. 15 minus 18 is minus 3 divided by 3 is minus 1. Well, we'll find b. Minus 3 minus minus 5 is 2. Actually, we found the key, let's say, the change parameter or the difference of the arithmetic progression for several columns and rows. Well, let's go back to the plate and actually replace everything. D turned out to be equal to minus 5, C turned out to be equal to minus 1, and it turned out to be equal to 18, and B turned out to be equal to 2. And also, in principle, we can already erase our paths, because, in principle, they played a role, they gave us the differences of our columns and rows. And then, in fact, we will begin to use the properties of the arithmetic progression, that each next cell will differ from the previous one by exactly the difference that we found, while everything corresponds to our directions. That is, if we have a difference, for example, of the second column minus 1, then when moving from the bottom up, each next square will be 1 less than the previous one, that is, the square above 16 will be 15, well, respectively, under 16 17 and so on 18, 19. Well, we immediately see that, for example, in the very bottom line, where we have a difference of 18, we have already built up logic. Even if we did not know this difference of 18, we would still have been given this difference by the first two squares. Therefore, we continue our reasoning. 19 plus 18 is 37, plus another 18 is 55, and plus another 18 is 73. Here, we are working further. Well, consider for example the very top line. There we have a difference of 2 and the movement is from left to right, so each next cube on the right will be 2 more than the cube on the left. Therefore, starting from 15, 17, 19, well, 21 just got into the conditions. Well, respectively, when moving in the other direction, 2 less, so the first square is 13. Here. Well, let's take the third column. When moving from the bottom up, each next square will be 5 less than the previous one, so the next square from the bottom up from 37 is 32. The next one is 27, then 22 and 17. Well, it's pretty easy to fill out the rest, because we already have 2 adjacent squares for each line. For the second, third, fourth line, that is, we can immediately sign their difference. Well, for example, for the second line from the top, the difference between 2 adjacent squares is 6, which means the difference of the entire progression is 6 when moving from left to right. That is, each next one on the right will be 6 more than the previous one. Therefore, the next one after 22. This is 28, then 34, well, the very first one is 10 in the direction of reduction. The same is true for the third line from the bottom. Here the difference is 27 minus 17 10, so 37 and 47. Well, here it's just 7. Well, in the last remaining line, we have a difference of 32 minus 18 is 14. That's why there are 4 here. Well, 32 plus 14 is 46, but here 60. Well, we can also immediately carry out, so to speak, a control check on the pillars. We see that in the first column, when moving from bottom to top, each next square is 3 more than the previous one. 1 plus 3 4 4 plus 3 7 7 plus 3 10, 10 plus 3 13, that is, there is a difference of 3. Everything fits. Next. The fourth column. Here it is obvious that the difference is 9, because 55 minus 9 46, 46 minus 9 37, 37 minus 9 28, 28 minus 9 19, and in the last column the difference is to the minus, because we are going downwards. Here, well, here different, respectively, will be 13. The fact that 73 minus 13 is 60, 60 minus 13 47, 47 minus 13 34, 34 minus 13 21. The problem is solved.